Hey class, so this is the second practice sheet that's due on Wednesday, and I just want to make sure that you get a couple examples and I get to explain pretty much what's going on. So one of the things I'm going to show you here is that we have the covalent column, we have the ionic column, and then of course I have a mixed column. Let me show you what the difference is. When we take a look at a compound like the formula, I notice that the first element that I'm underlining here, that's not the one I wanted. Hang on a second here. Sorry about that. Let me get rid of that. There we go. Let's try this one more time. The first element is N for nitrogen. Notice that N, if we look at a periodic table, and my periodic table here I have outlined. I have nonmetals over here, outlined in red. These are the covalent compounds when the first element. What that means to you is that we're going to be using the prefixes for those. Okay, now those are the same prefixes that you saw for the 6.2 naming covalent compounds, the mono, di, tri, tetra, penta, hexa, septa, what is that, octa, nona, and deca for like 1 through 10. Notice that for ionic, that what I have there is sodium, Na, and Na is on the blue side over here with the metals, and that's why it's ionic, because it's a metal and a nonmetal, which is what an ionic compound is. So we name them differently. So let's go back to the first one, the covalent. Here's the easy way to do it. The first element gets its natural name, as in when you look on a regular periodic table, it doesn't have the charges, or your list of elements in the reference packet that we've been using all trimester long. N is for nitrogen, so nitrogen gets written just like you see it with no prefixes because there's no number after N. But there is a number after Cl, and that's always Cl. Some people look at that and say, is that Ci, carbon and iodine? And it is never that. It is always Cl, and there I made a cursive L because that's for chlorine, and chlorine is very common. So soon enough you'll get to understand that Cl is obviously around a lot more than carbon and iodine. So nitrogen, and then the second part always ends in the IDE, just like the periodic table that has the charges on it. And if you don't have this periodic table, I'm going to attach it to this assignment so that you can see that. Okay, let's keep going. So nitrogen and then chloride gets the IDE. Chlorine changes to chloride, and that's on that periodic table. It has the charges. And then what you look at then is I write down, instead of chloride, I'm going to show that there are 3 chlorides by trichloride, like that. Okay, I'm actually going to move that down here so I have a little more room. So nitrogen trichloride is the name of that compound, NCl3. I do exactly the same thing for number 2. 4 is tetra. The prefix for 4 is tetra. P is phosphorus, so it's simply tetraphosphorus. And then 10 is deca, and it's always for oxygen, deca oxide. Oxygen changes to oxide when it comes second, which it usually does. There's 2 examples there. You can do the last 3 by following the same pattern I did. If there's a number, use the prefix in front. If there's no number, no prefix. Okay? So try that, see how that works for you. Now I'm going to jump 2 places here to 6 and 7 and show you some examples here. Now, when we go the opposite direction where I'm given the name and have to write the formula, I write down the symbol. The symbol for carbon, that's not what I want. The symbol for carbon, carbon's right here, the symbol is C. Okay? So I put C for carbon, dioxygen or dioxide. Okay, the di part is the subscript part. Oxide is still oxygen, so that's O, and the di is 2. So the di means 2 there. That's why we call it dioxide, CO2. Okay, the prefix for the element is the subscript for the symbol. Okay, I do the same thing here. Notice that when I have 1 for the second element, I get mono. So nitrogen, I don't use mono for the first element. Nitrogen is just N, and then oxygen like this, but because it's mono, it's 1, but we don't write 1s at all. So it's just NO. Okay, so that's my explanation for the covalent. I'm hoping that you guys understand how to do that. Let's take a look at my explanation for ionic. Ionic works it's actually, in my opinion, just a little bit easier, simply because we don't have to mess with prefixes at all. As a matter of fact, I make it a point to show that there are no prefixes when we have an ionic compound. What's an ionic compound again? It's when we have a metal that comes first. That's how we know that it's an ionic compound. So I write down the symbol for Na is, well, that element is sodium. I write the name down, sodium, just like that. The negative part is the N. When there's only one letter, I look on that periodic table and it says nitride. It ends in IDE, okay? So that's an easy one because it's just sodium nitride. I'm just naming the positive part, which is sodium, and the negative part, which is nitride. The second one here, I have barium. So I write down barium, just like I did sodium. Now I have more than one capital letter after barium. So I'm going to be looking on the top. It's called a polyatomic ion, and it usually ends in an ATE or an ITE instead of an IDE like elements do. Okay, so SO4, you look at the top of that periodic table within that box and you look for SO4, and what you see is something that looks like this. It says sulfate, and then you see the SO4 with a 2 minus like that. That's what you're looking for. So all I do is write down the name sulfate. This is so easy. All right, so barium sulfate is the name of my compound there. Now what if I'm writing the formula for a name of an ionic compound? Well, that gets a little bit trickier, because what I have to do, and that's what I'm going to do, I'm going to add it on to here so you can see it. What I do is I write down the symbol and charge and symbol and charge. Sodium is the first element. Everything after that is the negative part. So sodium's the positive, monohydrogen phosphate is the negative, and that's a mouthful. So the first part is sodium. Sodium has a +1. The second part is monohydrogen phosphate, which is H. That's tough to see. Let me get rid of that. HPO4 with a -2. Once I get to this point where the plus part is written with a charge and the minus part is written with a charge, and then I look to see that there's a +1 and a -2, which means they don't equal 0. The 2 comes down here as a subscript, and what I get then as my final answer is Na2HPO4, and that's it. Remember, I crisscross. The 1 crisscrosses down this way, but we don't write 1s. Okay, let's do one more just to check to see what's going on. Iron 2, take a look on the periodic table for iron 2. What you will see is this, Fe with a +2. The chromate ends in ATE, which means it's up at the top box, which means it's a polyatomic ion. And the polyatomic ion's formula is CrO4, and that has a -2. Now here's the cool part about this. When I got a +2 and a -2, all I have to do then is get rid of these charges. So the +2 and the -2 go away. So I just have FeCrO4. I don't need to crisscross when they equal the same, but opposite charges. Okay? So I'm going to take just one more minute here and go back to these where it says mixed. So all I'm going to do is look at the first element. If the first element is in the non-metals, then it's going to be a prefix or covalent. Okay? If the first element is in the metals, like this is, then it's not, there's no prefixes, and I just name it like an ionic. So no prefixes, and I name it like it's an ionic compound, because it is an ionic compound. So look at the first element for all of these, and you can tell what you need to do. It's either the first column for prefix or second column for ionic and no prefix. Okay, good luck. I hope you can do well. Please ask questions if you need any help.